So how does this work? Okay, so let's go ahead and try our best to parse this out. Let's go ahead and move you down here to this screen, and there we go. And there we go. Hey, look at that. That's interesting. Oh, right, so escape out of there. Alright, so we've got our items here, so we've got our nodes here. So the first thing we do is that we set this head equal to current. So this head is also current. It's not also just simply because this is holding A, this is holding B, this is holding C, this is holding D. Don't let that confuse you. It's not also called A, B, C, or D, right? This one has the variable head, current and head storing its memory location right now. I'll go ahead and remove the A, the B, the D, and the C because I think they will just be confusing, right? So let's look at this loop. While current is not equal to null. Is current equal to null? No, it is not. It is currently the head of the list. It exists, so we are going to go ahead and execute this piece of the loop. Okay, the output plus equals the current. We go into current, which is this item. We ask for the item. We get it we convert it to a string, and we append a space after it just so that we can get a output. Okay, that part's not scary at all. This part is the one that's possibly confusing. Current is equal to current.next. So this says take the memory location that's stored in current.next and stored in current. Well, what is the memory location stored in current.next? It's this node stored in current. One way to think about it is, and do I have a text tool over here? Let's see. Insert text box. F2. One way to think about it is rather than putting labels here. Another way that some people prefer to think about it is that we have a variable head, right? And it points to this guy, the head of the list, right? We also have, and I'll put it here, current. All right, and right now, when we began, current was referring to this node. Well, now we're saying take the memory location stored in current.next and stored in current. So that means we take this, and actually we're pointing now at this guy. Okay, that makes sense to everybody. We're taking the next node's memory location and storing it in current. So now current's updated memory location has the second node in it. Then we take its output and we run current.next gets stored in current again. So the memory location of this thing gets stored in current. So now current is this one. And now current.next, and then we go through this again. Current is equal to current.next. So we advance. So this literally think of current as a finger, right? And we're advancing our finger essentially from here to here to here to the next one. And now current is equal to current.next. Well, this is equal to, whoops, grab the wrong thing. So current.next, whoops, current.next, in this case, is equal to null. Right? This guy's not next is not, it doesn't store anything. It's null. So current.next is, so now we're storing null inside current, so current is now equal to null. So the loop terminates. So this allows us to go through the loop, right? We start here. The current.next allows us to advance. We start here. The current.next allows us to advance to the next one. This says take the memory location stored in here, and that is now current. Then this becomes the current node, and this becomes the current node. So this allows us to iterate through our list like that. So let's go ahead and use that to write a helper method, right? That it's one that we're going to use a lot. Okay, so let's go ahead and go back up here. Okay, this will be a private method because what it's going to return is it's going to return a node, right? getNode at int index. So given an index, I'm not returning the item at the index, I'm giving you the node back at the index, right? So we're going to use this while loop to our advantage, right? Essentially, we're going to recreate the same thing in our while loop, and this will let us also do the third scenario 3 of the add method. We've confirmed that scenario 2 works, by the way, by just testing it a bunch of times, right? Interesting that my computer updated and started playing. The other computer behind me started playing in the background. I've never seen Windows do that before. All right, well. Right, so if I run this anyway. Oh. Let's squelch that error so that we actually get an output here. Right, we have 4 B's and an A. Awesome. All right. So now the getNode, which we're going to need to use, what we'll do is that this will retrieve a specific node. So what we'll do is we'll use node e current is equal to head again. And I'm not going to bother checking for this one is out of bounds since it's a private method. So it should only be called by methods that have already checked whether or not the thing's going to be out of bound. That makes sense. This should only be when this gets. We don't need to do any kind of checking in this method because things will have already been checked. And what this will do is that this will return. Basically, we'll advance ourselves to the correct node, right, from here to here to here to here. Okay. And then we'll go ahead and return the node that we landed on. Okay, now that's going to be running a specific number of times. So rather than doing a while loop, I'll do a for loop, right? And what this will do, right? For I, boom. For int I is equal to 0, I is less than blank. We're going to leave that blank for right now. I plus plus. What's the body of the list going to be? Of this loop going to be? Current is equal to current.next. Right? This is the thing where I take this and I advance myself I advance my current to the appropriate node. Okay? Right? We're going to start out here. This is the node at index 1, by the way. This is 2, this is 3, this is 4. This is index 0, this is index 1, this is index 2, this is index 3. Got ahead of myself there. Okay? Right? So right now we're pointing to the node at index 0. So the question is, this operation advances current by 1 node. So the question is, how many times does this need to run? Okay? Well, if I want to retrieve the node at index 0, then I want this to run exactly 0 times. If I want it to retrieve the node at index 1, however, conveniently, I just want it to run once. If I wanted, right, advance once. If I wanted to retrieve the node at index 2, I would have this advance twice. Once, twice. So that for loop would run twice. And if I wanted to get to the node at index 3, I'd have this advance, I'd have this advance once, twice, 3 times. In fact, it actually becomes fairly straightforward. I have this to get this node, I have it advance index number of times. Now this will be used in both the add method and the remove method. But given a node, this will return the node at that index. Alright, so we've got our helper method done. So now let's go ahead and see how do we add an item anywhere else.